Hello guys, welcome back to the channel Eat Code and Sleep. And today's problem is leetcode problem is longest common subsequence. So this is a good problem of a DP and recursion here. Okay, and how to solve DP problems when there is a string, we can learn from this problem. Okay, like how we can solve, how we can approach a string problem using DP. We can know by solving this problem. Okay, so this is the basic step to solve how solve DP problems on strings. Okay, so let us quickly let us check with how what are the companies asked this problem. Okay, so Amazon has asked Apple, Adobe, Karat, Microsoft, Uber, and these all are the companies asked mostly in the mostly this question only. Okay, so let us quickly dive into the problem and let us visualize what is the problem statement is. Okay, and there are given two strings, text1 and text2. Okay, so return the length of their longest common subsequence. Okay, if there is no common subsequence, return 0. Okay, so we need to return longest common subsequence of both the string 1 and string 2. Okay, so what is a subsequence here? So a subsequence of a string is a new string, okay, generated from the original string with some characters. Okay, so a subsequence can be a string generated from the original string. Okay, so generated from the string. Okay, so with some characters, it can be any character, but the order of the characters should be the same. Okay, and so this is the point here. So without deleted without changing the relative order of the remaining strings. Okay, we need to uh, remove that characters accordingly by not changing the relative order of that characters. Okay, so here, for example, ACE is a subsequence of AB CDE, but AEC is not a subsequence. Okay, so because it is changing the order of relative order of the string, right? So AEC is not a subsequence, but ACE can be a subsequence because it is following a relative order. Okay, ACE is following a relative order. So what we need to do is we need to find the longest common subsequence of both the two strings. Okay, both the strings. So whenever we read this question, I think the only approach we will get in our mind is the brute force approach, right? So what will be the brute force approach? So for before solving the brute force approach, like how we can get subsequence of a string, like how we can get subsequence of a string. Okay, so if you want a video of calculating how we can calculate subsequences of a string, then comment down below. I'll be posting that video also. So basically how we will be calculating subsequences, like just picking that string and not picking the string using a recursive approach. Here, by picking or not picking, we can get the subsequences of the string. So uh, for example, if you want the subsequences of AC, so what are the subsequences? A can be subsequence, C, E, and AC can be, AE can be, and CE can be, and ACE, right? And the empty string is also a subsequence because it doesn't change any relative order of the original string, right? So ACE and empty string is also called as subsequence here. Okay, so these are the subsequences we can generate. So now we know how to generate subsequences, right? So the brute force approach, what will be the brute force approach here? So what I can say is I will be finding all the subsequences of uh, text1 and all the subsequences of text2, and I will find the longest common subsequence between those subsequences. Okay, so in this way I'll be solving the problem. But if you think if you if you think what will be the time complexity here? It will be 2 to the power of n for generating all the subsequences, right? So it will be more, right? So if you consider here, so if you think of a constant here, there are 1000, so the length of the string can go up to 1000. So 2 to the power of 1000 means it is so the time complexity will be so long, right? So it will be it will give us TLE, right? So for avoiding this, what we have to do is, so we have to follow a recursive approach. How we can solve this recursive approach using strings is now we will be learning. Okay, so okay, we can start it from so we have to, so in arrays what we were doing, we were picking an element or not picking an element, right? So in strings what we'll do is in same as arrays, but in strings what we'll do is, so we'll pick an element, we'll we will see whether the element which we are picking is matching or not. So in strings the matching condition will be checked, but in arrays the picking condition will be checked. Okay, so in strings we'll be matching the strings, matching the characters, but in arrays we'll be picking the characters. Okay, so we will check whether the characters are matching on. So either we can start from 0 or we can start from end. Okay, I'll be starting it from end. Okay, so now I'll be starting from here. For let us take this example a b c d e, and let us start it from e. So I'll, as I said, we need to match, right? So with the one character we cannot match, right? As this condition says, it should have a common subsequence. So it is already given that we need to match the subsequence with this and with this, right? So we need to have another index here, right? So we need to have one index here and one index here. So we need to check if they are matching, then we need to, so if chars of both strings are matching, then what we can do is, so we have initially I comma j, right? So I comma j represents the, so here I comma j represents the whatever the longest common subsequence is there at the, up to that it represents. So from n to I comma j, what is the longest common subsequence I have? Okay, from here until I. Okay, I is somewhere here, right? And n is somewhere here, right? From n to I, what is the subsequence? So this is what I represents here. Okay, so and this is what we need to keep a track of, right? So longest subsequence we need to keep a track of. So we need, actually want to find longest common subsequence on both the strings, so we have taken I and j here. So I and j represents what? I and j represents the longest common subsequence until I and j. Okay, until I and j until up to I and j indexes. Okay, so if, so the conditions which we need to follow is, so in any string dp problem we need to follow these conditions only. Okay, in array we might have doing, yeah, picking and not picking, right? Same as this only, we need to match or do not match. Okay, what if this if the characters match, what we need to do? If the characters do not match, what we need to do? That is the dp on strings here. Okay, so if the characters are matching, so um, let us take this as a, and let us take this as t string, and if s dot caret I is equal to s dot caret t dot caret j. Okay, if the both characters are matching, then what we can do? So what we can say, so up to here there is one character which is matching, so our longest common subsequence will be one, right? So our length of a longest common subsequence will be one. So we can return one plus, and we can call for we can go beyond that, after that, right? So we need to call I minus 1 comma j minus 1. Okay, so if the characters are matching, we can call I minus 1 and j minus 1, right? So if the characters are matching, we need to move both the indexes forward. We need to move both the indexes forward. So if what if, so what if the characters are not matching here? So for example, what I can say is, so AC is one example, and CA. So I initially I is here and J is here, right? So the characters are not matching here, right? So the characters are not matching, but if I move J here, the characters will be matched. without moving I with when I move j here. So if the characters are not matching, I and j are not matching, I and j characters are not matching. So by not moving I and by moving j, we can match characters, right? So if we do both the if we move both the indexes, then we will uh, lose the track of this common characters, right? This common character we will be we will be losing. So we have to not move both the indexes at a time when they are when the characters are not matching here. What we need to do instead, we need to move, we need to keep the I constant, and we need to move j here, or else we need to move j constant and we need to move I here. Okay, I forward. Okay, so here in the do not match condition we have two conditions. So we need to perform at do not match conditions. We don't have any common length, right? So we will initially return 0. So and we will return 0, and we need to find what we need to find, math.max of I minus 1 comma j. J is common, right? And uh, I comma j minus 1, right? What will be the maximum length when I keep my j when I keep my uh, j index as constant and move my I index, and what will be the length when I move when I keep my I constant and move j index. Okay, with these two conditions I can uh, from these two conditions I will get the maximum. I will take the maximum length and I will check, I will get, right? So in this way we need to do this problem. Okay, what we need to do. So in strings, basically there are two conditions: matching characters or do not matching characters. If the characters are matching, what we need to do? So if the characters are matching, we can take it as a count. So if we can take it as an count, whatever the count. So we need to have a longest common sequence, right? So we can take that characters as a longest into take it into our length. So we should add one there, and we will move both the indexes to minus 1 and minus 1. Okay, I minus 1 and j minus 1. So if the characters do not match, so there is a possibility like uh, if we move both the, then there is a possibility like losing some characters, like losing some subsequence, right? Common subsequence, right? So for to check the to maintain that to not to lose that subsequence, we will be making one's index as constant and moving other index, right? And simultaneously we'll be finding from that both length maximum length, and we will be getting that maximum length. Okay, by doing that. So this is the way how we will be solving this problem. And let us quickly uh, check the recursive tree here. For example, the indexes are at 4 and 2. Okay, this is the 2 index and this is the 4 index. From last time traversing, right? So from 4 comma 2, where I can go? So these two are matching, right? So I and so these the indexes are here, right? So the indexes are here. So these two are matching. If the characters are matching, what I need to do? I need to add one and I need to move my characters to here, right? So I'll move the indexes here. So now you can see the indexes are not matching here. So what I can do? I can keep one constant and move another, right? I'll move one constant and I will move another. And what I can other what is the other condition I can do? I'll keep this constant, I will move this one here. So that is what two common, and I'm moving. But I'm decreasing two in index, and I'm keeping one as j index as constant here. So from these both two, I'll get the from here again there will be condition whether the characters are matching or not. If they are matching, then add one and move both the indexes. If they are not matching, keep one constant and move one index. Like same condition for these two, right? So this is the uh, recursive tree. This tree will be very large, so I haven't got time to draw a whole tree here. So So this is what the a tree will look like. So let us quickly uh, try to solve this try to code it up the recursive solution. Okay, so now, so as we are going from last to first, right? So we will be calling a recursive function which is solve, and we are going from last to first, right? So text one dot length minus one comma, we'll be passing both the last indexes of both strings. Okay, text 2 dot length minus 1, and we'll be passing the strings here. Okay, so public int solve int I comma int j comma string s, considering a string text 1 as string s. Okay, and text 2 as string t. Okay, so there is a possibility that there is a possibility like the I index can go beyond 0, right? So it can go beyond 0, and this also j also can go beyond 0. So if that if it goes beyond 0, that if it comes to minus 1 or something, so then uh, it is an out of bound condition. So in that case I need to return 0, right? So I'll that will be the base condition here. Okay, so if I is lesser than 0 or j is lesser than 0, in the both conditions we need to return 0, right? I'll be returning 0. Okay, or else I am at the valid indexes. Okay, now I need to check, I need to have two variables, right? One is match and one is do not match. Okay, I have initially I'll be taking them as 0. So I'll be having, I need to check whether the characters are matching at that indexes or not. Okay, now I need to check. So if s dot caret I equal to t dot caret j, then this is a match condition. So I need to move both the indexes. By moving both the index, and I need to add one to that problem, right? So the matching condition is satisfied. So I got the one length longest common subsequence from both the strings, right? So I need to add one here. Okay, and I need to call the recursive function, and I need to pass the parameters as I minus 1 and j minus 1. Okay, so this is how I'll be solving the matching condition. Else, so else is a do not match condition, right? Else will be the do not match conditions. So if the characters do not match, what I need to do? Don't match math dot max of solve I minus 1 comma j, keeping one constant and moving other index, and comma solve keeping I constant and moving j index, right? So these are the two conditions I need to follow, right? So I'll check, and with this I'll get the integer, right? Maximum length, right? So from this I'll storing at the do not match condition, I'll be storing the maximum length of these two conditions. Okay, so after here I'll be returning what I'll be returning. I'll be returning the maximum length of match and do not match, right? So I'll returning math dot max of matching condition comma don't match condition, right? So this is the recursive solution here. Let us quickly run this solution. So it is passing. Now as the constants are more, so this recursive approach takes up to 2 to the power of n, right? This also take up to 2 to the power of n, right? So uh, uh, this is also not a better approach, right? This is a brute force approach, right? This is also not a brute force approach, but this is a recursive approach, right? Uh, we need to optimize the solution also, right? So for optimizing a recursive solution, what is the uh, alternative solution? That is the dp solution, right? So we need to have a dp here. So our dp case, what will be the what will be the what dp we need to take here. So according to the number of parameters, what are the parameters changing here, according to that we need to take our dp, right? So here I and j are changing. So what will be the dp here? It will be 2d dp, right? So we need to take 2d dp, and the length of the 2d dp will be, so as I and j are indexes of strings, so it will be uh, first length plus one and second length plus one, right? So uh, so that will be the length of the dp. Okay. And what dp stores, actually it will stores dp of I comma j says until here, up to here, from n to I comma j, from dp I comma j, what it says is up to here I got the dp comma I comma j, I got what it says is I, what it stores is the longest common subsequence up to I comma j. Okay. At I comma j, at I comma j, what is the longest common subsequence I got? So it will store. Okay. This is the instance of dp. Okay. So what it will be, text one dot length plus one, right? And text two dot length plus one. So this will be the um, uh, what is length of the dp, and we need to pass, we need to fill the dp with minus one, right? A belongs to dp, and arrays dot fill a comma minus one. Okay. And now we need to pass dp as a parameter here. Okay, I passed dp as a parameter, and I need to also, and after passing dp as a parameter, after checking the base condition here, what I need to check, whether the dp of I comma j is a positive value or not. Okay. So we need to check it. Is there a value in dp I comma j or not? Rather than I minus one, is there a value in dp I comma j? If there is a value, then the subtree of the dp of I comma j is already calculated. So it is already calculated, and it is stored in dp I comma j. So so we can directly return from that, right? So if dp of I comma j is not equal to minus 1, then we can directly return dp of I comma j, right? So I have written dp I comma j here. So afterwards, what you need to do, we need to store, right? We need to store here. So I've successfully stored the dp of I comma j, and I have written dp of I comma j whenever the dp of I comma j is not equal to minus 1. So what this means is, if dp of I comma j is not equal to minus 1, then it says uh, dp of I comma j length, the dp of I comma j, what it says, the longest common subsequence at I comma j, right? At I comma j, the longest common subsequence is already, we have already calculated for it, and we have stored in dp of I comma j. So at this time we need to, so this says that thing. So we need to return that longest common subsequence at dp of I comma j here. Okay. So this is how we'll be solving this problem using dp here. And when we try to run this problem, let us try to run this problem. So we haven't passed the parameters here. So comma dp and comma dp comma dp. Right, it is will let us try to submit here. So it is accepted, right? So we can also solve it by traversing from starting to ending. Okay, as we have traversed from ending to starting, right? So if we traverse from starting to ending, then we need to move our indexes by plus one. Okay, we need to move our index by plus one. So this is what the change we need to do whenever we are traversing from 0 to end. But we are traversing, as we are traversing from end to 0, I have moved it forward. Okay, I have minus one here. I have did minus one here. If you are moving from 0 to 1, then we need to do plus one here. Okay, so that is the difference here. And coming to the time complexity here, the time complexity will be big of n square here. Okay, big of n square, as we are moving for every possibility, right? Every possibility, like from here I am moving to every possibility here, from here I am moving to every possibility, so this will be n square here. Okay, the time complexity will be l square, and the space complexity will also be n square here. Okay, tc belongs to big of n square here. Okay, and sc belongs to big of n square here. Okay, these are the time complexity and space complexity of this problem. Okay, thank you for watching this problem. Subscribe to the channel, and thank you.